Hello friends, today I'm going to solve LeetCode problem number 2246, longest path with different adjacent characters. So in this problem we are given a tree with n number of nodes numbered from 0 to n minus 1 and the root node is equals to 0, and we are given parent array where parent I is the parent of node I, and we are also given a string s where the value at index I is the character that is assigned to the node I, and what we need to return is the longest path, the length of the longest path in the tree such that no two adjacent nodes in the path have the same characters assigned to them. Now in this example, what do we have here is index 0 has character A but index 2 has character 2, so we cannot take this path. So we can either take the path 2 and 5, that would be of length 2 because these two have different characters, adjacent characters are different. We could take path 0 1 because the adjacent characters are different, and we can also take the path 1 and 3 because the adjacent characters are different, and we can take the path 0 1 and 3 as well. So the longest among all of these would be 0 1 3, right, which is length 3. So that is what we will return. We return the longest length of the longest path. Now let's see how we could solve this problem. So I have created an example of my own. This example will give you the clear idea of what things that we need to keep in mind while solving this problem. So we'll solve this problem using bottom of DFS approach. So we start from the very top and then we go, since it is DFS, so we go to its very end. So from here we go towards the left until we have reached the end node. Now we have reached here the end node, right? And before that we will initialize our longest path to be equals to 0. So far the longest path is equals to 0. Now we have reached here in the tree the very end and the length of this subtree. So we are only considering this subtree, the maximum length of this subtree without any adjacent nodes having the same character is equals to 1, right? So the longest length so far is equals to 1. So what we do is we update the value here to 1, and then we return the value, we backtrack to its parent and we return the value 1 to its parent. Since it doesn't have any more children, so the length of these subtree becomes equals to the value from its child and plus 1 considering the node itself. So plus 1, so that would be equals to 2. So this is the value we return to its parent node. Before returning, we again update our longest path. So now our longest path is equals to 2. Now we have returned the value 2 to its parent node, which is from its left child. Now what about another child? So here again, only this subtree is of length 1, right, is of length 1, and again we check that C and B are of different characters. So we return the value 1 here, 1. So the value returned from one of its child is 2, the another child returns value 1. So we take now what we need to find the longest path, right? So one of the longest path here becomes 2 plus 1 plus the node itself, that would be 2, that is this subtree, plus 1, which is this subtree, plus the node itself. So this becomes one of our longest path. So the value becomes equals to 2 plus 1 plus 1, which is equals to 4. So we update our longest path, the longest path is equals to 4. Now what we need to do is we also need to return a value to its parent node, right? To its parent node. So what value will be returned? We are not returning the value 4, that is the longest path. We do not return that. We return the value of the longest child. So we only return the longest child. Okay, let me just clear this up here. So just by looking which is the longest child, this one is the longest one, right, in comparison to this one. So since this is the longest child, which is of length 3, so that is what we return to its parent. We return value 3. So we return the value 3, and then similarly for this case, the longest child here is of this is of length 2, and then we return the value 2 here again, and then we have 3 plus 2 plus 1, which is equals to 6. So we update this value to 6, and now we have the longest length, which is something like this. So let me just again clear this thing. So the longest path here is like this. This one is the longest path. So we have how many nodes? 1, 2, 3, 4, 5, and 6 nodes, right? So far this is the longest node, and we also need to return a value to its parent node. So what we return this length, the longest one. So actually we take the longest, for this node we take its longest child, and since this is the longest child, okay, for this node, since this one is the longest child, right, because this has length 3, this only has length 2. So since this one is the longest child with length 3, so we take 3 plus 1 for this node itself, and we return the value 4 to its parent. So similar is the thing we do towards this side as well. So let's just see. So this one, from here what we get is of length 2, and from here what do we get? Since these two have same label, so we only get the longest path here would only be 1, that is this subtree. So the 2, we return 2 plus 1 plus 1. So this, in this subtree, the longest path would be this one, 2 plus 1 plus 1, that would be equals to 4. But the longest child here is this one, right? So this one is the longest child, so we return 2 plus 1, which is equals to 3 to its parent. So the longest length would be 4 plus 3 plus 1, which would be equals to 8. So the longest length here would be equals to 8. So basically from this example we know that we need the long length of the longest child as well. But here I have only shown you the example with 2 children, right? Each of the parent have 2 children. But what if we have more than 2 children? If we have more than 2 children, that is more, then in that case we need the longest length of the longest child and length of the second longest child. So we need these two things to find our longest path. Now let's try to write code. So what do we need is, let me just define the value n as the length of the parent, and now we need our adjacency matrix where all of the children of our parent node, so that would be of length n. And since each of the children, each of the child is also an array, because So that is what we do, and then we finally fill in the value of the children from our parent array. So children of the parent at index I is the index I itself, right? So we will push that value to our children array, and then now we have this. Let us define our longest path to be equals to 0, and then let's define our DFS function. Since we need, what do we need? The length of the longest child and the second longest child, right? So we'll define these two values also to be equals to 0. So longest child equals to 0, and second longest child, okay, I'll just use child and child 2, both of them are equals to 0. Now we loop over each of the child of the node, each of the child, and then since it is a bottom-up approach, so we will first of all do our DFS before we perform any of other evaluation. And the value, since each of the child is returning a value, right, from to its parent, the value is the length of its child, length of the child path, right? So length of the child is returned from its DFS function, and after that we also need to check if the character of the node is equals to the character of the child. If that is the case, then we will continue, else we will perform our evaluation. Now here, to perform this comparison, to access the string as using the index, it should be in the form of arrays. So what I'm gonna do is I'm gonna split the string so that as becomes an array. Now we will be able to access the string as in the form of array using the index operator. Now we have that, and if we compare and see if both of the the parent and the child, if they do not have the same character assigned, then what we need is the characters are different, then we will we need the longest and the second longest child, right? So the length, from the given length we will find the longest and the second longest. So if longest length is less than the length of the child, which means that we found our longest length. So before that, okay, not the longest length, but if the, okay, let it be the longest length of the child, longest length 2, then we found our longest length. So before that we assign our longest length to the second longest, because that would become the second longest length, and our longest length becomes equals to the length of the child, else the longest length is the same, but if the second longest length is less than the length of the child, then we need to update our second longest as the length. Right. So now that we have done this comparison, we find our longest and the second longest of this node, of this given node, by performing the DFS operator on each of its children, on each of its child. Now once we have that, we update our longest path. Longest path is the overall path. So longest path will be the maximum of either the longest path or longest length of its child plus second longest length plus 1. That would be, in case of this node, that would be the longest length. The second longest length would be this one plus 1. So once we have found our longest path, now we return our longest length plus 1 to the parent of this node, right? So now that we found the longest length for this subtree, right, we found the longest length to be this plus this. Now we return the longest length to its parent, right? So we need to return to the parent the length of the longest child, which would be this one, right? This one. So that would be the longest child, length of the longest child plus 1. So we return the value to its parent. Now that completes our DFS function. So now we call our DFS function and then we return our path, because our final answer is in that value. Now let's check our code. Okay. Okay, something went wrong here. Okay, so the spelling mistake here. Cool, let's submit it. So the space complexity here would be equals to, because we are creating our adjacency matrix, so that would take space n. So that would be of n space complexity. And now talking about the time complexity, this is also O of n, this is also O of n, and this would also be O of n, because we are only calling the DFS function on its child once, right? So since the total would be O of 3n, but we disregard the constant, so the time complexity will be O of log n only.